Once again, I want to say a big welcome to all of you to the Valley of the Shadows of Management Science. Look at this thing, torture numbers, and they will cry, Fefe. Torture numbers, and they will cry, Fefe. You're about to torture numbers, guys. I will help. If you don't torture the numbers will do what to you? They will torture you. Be ready to torture the numbers. Tell yourself, dog, bring it on. Anytime I'm teaching you, and then something is not going well, say, dog, bring it on. I'm ready for you. I'm ready, bring it on. And that confidence will exude in you and elevate your mental gymnastics to the highest apogee. Bring it on. Be so confident, be so positive that negative people don't want to even be closer to you. That's how you gotta be. Be so positive that negative people don't like you, which is better. So I want to say a big welcome, okay, to the Valley of the Shadows of Management Science. There's a guy called Alexander the Pope. He said a little learning is a dangerous thing. Drink deep or taste not the Pierian spring. There shallow drought will intoxicate the brain, and drinking largely sobers us again. You have not been reading some Shakespeare books, eh? Some of them. You will have every lecture on the YouTube. Go there. Previous lectures are there right now. The past 3 years, previous lectures are there. So every topic, there are 3 videos already, including the one that I will add from yours. Play this thing in your car. Play it when you are in a smooth movement. Stop listening to the radios and the lectures and the news. They are not going to do anything great. Whatever is coming that is negative, you will hear it on WhatsApp. And every time you are in your car, in the house, start playing these videos into your brain. Your brain in your subconscious state will activate the answers to this. I'm telling you, turn off your phone. When we are in the class, or even when you're alone, turn off your phone. It helps you to understand what is going on. Let me know what is working and what is not working. Early on, don't wait till last minute. This course requires you to think, but you will make it. Trust me, you have conquered the course. I say you have conquered the course. Okay, you have conquered this course, and you will. Tell yourself that every day before you leave the house. If you write it there on your fridge, you see it every day. I have surgical appointments. In case you want to see me, okay, quickly make an email appointment and I will arrange to you. I can do you a WhatsApp call. Do you see that I'm one of the few people to have actually set up a WhatsApp group with you? Have you seen that? Or every lecturer has done that? Redeemer, has every lecturer done that? I'm one of the few.
The only person.
The only one.
You see? What does that tell you? What does that tell you? I love you. I want you to grow. I don't want to distance myself from you. I understand your condition you are in. For the next 2 years of your life, your brain is going to go semicircle. You're going to sacrifice weddings. You're going to sacrifice outdoorings. You're going to sacrifice funerals. Your life is going to be stressed. I don't want to add any more burden to that. So I want to be communicating with you. I want you to be with me, to be on the page with me, interact with me. Let's laugh, let's relax. That's how you learn. Learning should not be changing. You know, I'm learning, please, get away. No, that's not learning. Learning got to be fun. You got to be interacting. It has to be part of your life. You never stop learning. Learning is knowledge. Knowledge is in continuum. Knowledge is infinite. Every other thing is finite. Knowledge is infinite. It has no end. That is why God is the source of knowledge. You do IAs, you do exams, you do several things. So, strategies for success. Be of good courage. Don't defeat yourself. Don't say negativity about a course. Even if you think it's hard, say it's easy. I'm telling you. Later on, I'll teach you how your subconscious mind works. Yesterday, your brain produces 90,000 of information. 90,000. Guess what? 89,000 of the 90,000 are all negative. Today, your brain will repeat those negativities. So it means that you got to be positive. Then more positivities are reinforced in your cerebellum. Put in the time, put in the energy. Anywhere is a walking distance. You will pass. You can pass. Just have some time for it. So let's start. What is management science? This is management science. Please note, management science is not the same as management. Management science, one key word is quantitative analysis. It's quanti. If there's ever been any quanti in your life, it is management science. It's a science. What it does is that it uses mathematical models, procedural analysis, systematic solution to procedures. We normally call this algorithms. It uses those mathematics, statistics, algorithm, computational technology to tackle complex, not simple, complex real-world problems. You see, in this world, when people are complaining about problem, yours is to solve the problem, isn't it? Once you solve the problem people are complaining about, you become a millionaire. You don't join them in complaining about a problem. Go and bring Mahama, Nana, Osama, Obama. Nothing will change in your world, in your economy. So you got to solve the problem inside. There's an African proverb that says that if there is no enemy within, the enemy outside can do you no harm. Sometimes you are your own enemy. Management science tries to use quantitative analysis to solve the problem. It started long ago in the war, the Second World War. That was when the British and Americans, the military, you see, the military used a lot of strategies to overcome the Germans. And they used military strategies. After the war, they didn't know what to do with those strategies again. So the strategies started moving into engineering, manufacturing, transport, health, business. And now those strategies, those war-torn mathematical models are now being used to solve complex business problems. Artificial intelligence is part of that. That is management science. So management science basically is using quantitative analysis, mathematical models, statistical models, computational analysis, using these to solve real life, serious real life complex problems. It could be problems about human beings, problems about companies, problems about universities, problems about the government, countries. It doesn't matter what the problem is. You can use these techniques. And I'm going to show you some of the management science techniques. Now, if you want to answer these questions, management science can easily help you. I want you to know that this thing you're about to do is very practical. What we're about to do, guys, is practical. How can our company compete better than the others? Do you want to have a competitive edge? Do you want to have a competitive edge in your company right now over the others? Management science can help you. In fact, let me tell you guys, if you learn this thing well, most of you can become consultants, like I am. You can become consultant. Because these things, once you apply them, once company sees the numbers making sense, you will smile. How can managers decide ahead of time in the presence of uncertainties what to produce, how much to charge? What should we produce? How much should we charge? I want to assign the task to the production manager, but I want the marketing manager not to interfere with that task. How do I do it in such a way that there is no interference? Management science can address that. There's so much queue at the banking hall. There is so much queue at the banking hall. How can I reduce those queues? You think it's a human problem. It's not a human problem. It is a real-life complex problem. You can use queuing model. We shall learn queuing model in week 9. You can use queuing model to solve that problem. What's my point? Management science is practical. Let me tell you, in the past, management science has done the following. There's a group of American airlines, their management science group. They use one of the techniques we shall learn. It is called forecasting. They use forecasting and optimization to offer discount. And they were able to maximize the revenue of American Airlines. Guess what? They made $1 billion every year because of the management science model they used. In South Africa, the entire defense force, they redesigned the size of the Defense Force. And they were able to, the entire weaponry system in 1997, they redesigned it. They used management science system to do that. And they saved $1.1 billion. Management science is happening live, guys. It's happening live. But wait, in your life, in your own life, let me show you where management science is. Now, let's assume that you schedule a holiday, you want to go to London. There is something, you know, whenever you want a cheaper flight, you go to, I don't know, sometimes you start with Google. Google will take you probably to Skyscanner. I don't know, you know, if you have been able to do that. Some of you, you don't travel, really. You don't travel across the night. You got to travel. You got to travel far away, you know. So anyway, so when you are traveling, you normally want a cheaper flight. You use Skyscanner. Now, once you type Accra, London, it will search the entire system looking for the cheaper flight. But what you don't know behind the scene is that in the process, it is using an algorithm, and it is scheduling the flight crews and aircraft in such a way that you will get the cheapest flight. That approach is a powerful approach. They are using multiple management science models. We learn them. Now, if you get to London, you need to take a London black cab. The owner has instituted a management science program where the price you pay, remember price times quantity is revenue. The price you pay is a mathematical model that will maximize the revenue of the car rental company. Management science is at work. So management science is practical. It's for everyday living. Guys, by the way, let me put it on record. I can show you if you are in any country in this world and you are making 3,000. I don't care whether it's 3,000 cedis, 3,000 pounds, $3,000, 3,000 yen, any 3,000. If that is your amount you are making, at least 3,000, I can show you a system that will make you a millionaire in 20 to 25 years. Oh, by the way, many people are making 3,000 or more. And by 20 years, they are not millionaires. Do you know that? Yeah, I can show you. We have systems. We have knowledge to be able to create value. Anyway, so that is how practical management science is. Now let's take one of the techniques of management science. There will be a lot of them. But today I want to start with the basic, well, it's not basic actually, okay, the popular one. And we are going to do that. We're going to start mathematically modeling right now. And it is known as linear programming. Linear programming. The word linear comes from which word? Linear comes from which word?
Line.
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 Straight line.
So that means that when you're about to do linear programming, you will be dealing with lines. Guys, let me remind you, do you remember the Akiola equation of a line? Please, when you finish, call your little brother or sister or your child you have been insulting. Tell him to give you Akiola and teach you how to generate equation of lines. Learn the following. Learn equation of a line. Learn equations. Learn simultaneous equations. And learn inequalities. I've said my own. Learn it. It's not part of this. But once you refresh your mind before next week, you will follow what we are doing. Solve all the questions. Akila has got the answers at the back. Solve all the questions and you'll be fine. Linear programming is a mathematical model. It helps managers to check their relationship. But the relationship got to be linear. And they are able to use that relationship to maximize an objective subject to some constraints. You might not fully understand the definition I just gave, but as we go further and further, we should understand. Linear programming was first brought into the world normally around 1939 by Kantorovich. But the thing is that Kantorovich's work was not seen properly. It was hidden until George Danzig published something, a simple approach, which is called the simplest algorithm. Now, this simplest algorithm or simplest method It is a technique that you use to solve linear programming problems. Guys, when I say a technique, it's like you talking about a strategy. You know, football, there are some coaches that are always winning. Have you observed that? Why are they always winning? Because they have what? They have what? I want to hear. They have what?
A winning mentality.
They have what?
You have a strategy.
A strategy.
Experience.
A technique.
The technology.
Okay. They have a technique. They have a strategy. They have a method. So you don't just get up and win the match. You got to have a technique, a method, a strategy. Now, linear programming, Danzig developed the simplest algorithm, which is a strategy for solving. I will explain linear programming, the basic form for you today, but I'll make it practical. Write everything down. Even though I'm going to give you the slides, write everything down. Because when you are writing, there is an information symmetry between your fingers and your brain. So as you write it down, something is transmitted through your fingers to your brain. You don't know it, but I've learned how to learn. What are the elements of linear programming problem? Well, before you can solve a linear programming problem, you got to know the decision variable. The decision variable are the things you want to look for. You are looking for, you know them, you know the decision variable, but you're looking for how many of those things to bring into the world, to deal with. The decision variable, and I'm giving you simple language so that I can understand. It is those things that you got to make a decision. You got to make a thinking about in terms of their quantities. For example, and we are going to use this example, Farm Mill Ghana Limited. What are the things they normally produce? Can you mention some of them for me? What are the things they produce? Fan ice.
Yogurt.
Fan yogurt.
Fan yogurt.
Fandango.
Fan choco. Fandango. Fan pop. Exactly. These things are what we call the decision variables. These are the things they got to decide. So next time they got to make a decision about what other things should they bring on board. Maybe they have to bring fan muchocho. That is a whole new something. So the decision variable are the invisible aspects that you want to make visible. And you want to make visible, but the question is, how many do you want to make visible? Now, once you make that invisible thing visible, now that will help you to make money as a company. The next item in the linear programming language is called objective. The objective is whether you want to cut down your cost, increase your profit, or you want to reduce the time. Let me give you an example. If you are in a football match, what do you think the managers, not the football managers, the managers of the stadium where the game is going to be played, what do you think will be their objective?
That it should be filled.
What should be filled?
Stadium should be filled.
That is it. So their goal is to increase the spectator capacity. So that becomes the objective. I just want you to know that the objective is not always about cost or profit. If you go to a cinema, a theater, like the National Theater, what do you think the people who are doing the event want to do? What's the objective?
More people should come and then they also make more profit.
Exactly. Well, the profit will be determined more by the more people coming. So their goal is to fill that theater with capacity. So that becomes the objective. That becomes the objective. Now, if you are an employee of a company, usually what is your objective?
More money. Salary.
Thank you. Okay, I get you. Okay. So objective of a company is to maximize or minimize something. Now, please, that word minimize is very important because the government's goal during the COVID-19 was not to maximize COVID. The government's goal during the COVID-19 pandemic was to minimize the upsurge in COVID-19. Derek, go ahead. Now,
mistake, I'm going to say.
In order to reach this objective, you'll be limited by certain things. These things that you are limited by are called constraints. Constraints. The first can be time. You know, time is a resource, but it's also constraint. For example, right now, there is an opportunity cost of you being in this class. Right now. The opportunity cost of you being in this class is the next best funeral that you would have attended. But you sacrifice that towards this. So time is a resource that is restricted. We all have 24 hours. Labor is a resource. If you want to run a company, want to do a bumper harvest, you need labor. You need materials. If you want to do Farm Milk Ghana Limited, you need the materials, the sugar, the milk, the color, the types, the money. All of these are constraints. But look, these things looks like abstract, isn't it? Let's try to make it a bit practical. All right, let's go. I want someone to read this thing, not like the news reader will read it. I want someone to read it slowly, whilst others are thinking. Patrick.
Farm Milk Ghana Limited produces Fan Yogo and Fan Chocolate. Some Ghanaians love these. The two key resources used by the company are labor and milk. Given the limited resources, the company desires to know how many sachets of Fan Yogo and Fan Chocolate to produce each day in order to maximize profit. There are 40 hours of labor and 120 gallons of milk available each day for production.
Let's continue.
Fan Yogo requires 1 hour of labor time and Fan Chocolate requires 2 hours. Also, Fan Yogo requires 4 gallons of milk, whilst Fan Chocolate requires 3 gallons. The profit from a sachet of Fan Yogo is 40 Ghana cedis per unit, and from Fan Chocolate is 50 Ghana cedis per unit. Formulate a linear programming model for this product mix problem and solve using graphical analysis.
Okay, there's a lot of work there, but at least we have a story here. Now, the first thing you got to do are the following. Guys, you want to make note of these. You see, anytime you have a linear programming situation like this, it's like a simultaneous equation word problem. Do you remember those good old days? Simultaneous equation word problem. Kofi is 4 years from now. 3 years ago, he was 2 more years than his father, who is 53 years. If his father is 62 years, how old was Kofi 17 years from now if his father's age has reduced by 30 years? In some form, we used to learn these things. That is how this thing looks like. But in order to get it right, you should always break it down. How do you break it down? Break it down into 4 parts. Part 1, and I'm going to show you. Identify the decision variable. That is the first thing. Identify the decision variable. And looking at this story carefully, who can raise a hand and tell me what a decision variable is? Margaret. Patrick.
Yes, sir.
Hello, sir.
Yes, Patrick.
Hello, sir.
Yeah, go ahead.
They want to produce many sachets of fan yogo, and fan chocolate. So that's the decision they are making.
Good. So the decision variable is usually the quantity of the items that they want to produce. Write it down, I beg you. This is the basic and the easiest. It is a quantity of the items that you want to produce. So in this case, they want to produce a certain number of fan yogo sachet, and you always bring the unit of measurement, and a certain number of fan choco sachet. Now, how do you write the decision variable? Always represent the decision variable with letters. Write it down. Always do it. So you have to put something down like this. And in this case, how many are the decision variables? How many are they?
4.
2.
Two. There are 2. Now, please note that in real life, they are not 2. I've made it simple. That's why they are 2. Because apart from fan yogo and fan choco, they could be producing fan ice, fandango, tampico, and so forth. So in reality, the life is complex than it is now. But when you do it just 2, it will help you to draw and now understand. So we are going to use a letter to represent fan yogo and another letter to represent fan choco. And don't forget the unit of measurement. So we will say something like, let x1 be equal to, and then let x2 also be equal to. What do you think x1 will be?
Fan yogo.
Fan yogo.
Please raise your hand, because I know that some of you will get it right and wrong. It's not just mentioning the answers. Yeah, Bismarck.
So, Doc, so F1 F1 will be fan yogo.
Okay, if you say x1 is fan yogo, you are wrong. Let's go to another person. Gideon.
But I can try.
Don't worry, I said you are wrong. When I say you are wrong, don't correct it. Let somebody else talk, because I know that you'll be tempted to want to talk now. But I want you to think first before you raise your hand. Yes, Gideon.
X1 is the quantity of fan yogo you want to produce.
Not really, not exactly. You got to put it in a certain way so that the true unit of measurement is explicit, is clear. Let's go to another person. Faustina. We started though. We started the journey. Faustina, has your hand up? Or you were dancing? Okay, Dinah.
Okay, so you mentioned that we should represent the decision variable with a letter. So since we should say let x1 be fy, which is fan yogo.
No. The x1 is a letter.
Okay, sure.
Michael.
So let x1 be sachets of fan yogo and x2 be sachets of fan choco.
I like the way you started. You're closer. You're closer. So x1 should be the number. That's how you do it. The number of units or the number of sachets, because the unit should be properly mentioned. Sachets of fan yogo. Write it. Because by the way, if you check past questions, you will see that we always give marks for this. The number of is very important. And then the unit of measurement is mentioned. So if it was gallon, you would have written number of gallons of fan yogo. But this one is sachets. So number of sachets of fan yogo. To produce, you have to add to produce, because the actionable production capacity has to be included. To produce. To produce. Who can tell me about X2? This one, we call it atolai. Who can tell me about S2? Marvin.
Oh, thank you, sir. So X2 represents the number of sachets of fan choco to produce.
Perfect. Guys, if you haven't written this down, do it. So what we've done is that we've been able to indicate the decision variable. If there are other decision variables, You should be able to identify them and work them out. So that's the first step in linear programming formulation. So you will get a story, a preamble, which is what we have. You got to formulate this in a mathematical framework. And you start by identifying the decision variables, which is what we have just done. Our goal will be to find the number of sachets of fine yogurt they have to produce. In fact, that was part of the question. And you will see that in the question here. The question is, the company desires to know the number of sachets of fine yogurt to produce. That is a goal. Those of you whose hands are up, I've reduced them. If you have a question, you can raise them again. Let's go to step 2. Formulate the objective function. Diana, go ahead.
Please, I want to ask, if the variables are more than 2, should they follow? So x1, x2, x3,
Correct.
follows. Okay, sure.
Yeah.
Thank you.
Exactly like that. Now, if the second step is to formulate the objective function, formulate the objective function. Ladies and gentlemen, the objective function is generally represented by a letter, and the letter is Z. Z. Now, when you write that Z, you are supposed to go back to the question and read the question to know whether you are maximizing the Z or you are minimizing the Z. Now, Z can be anything. It can be cost, it can be profit, it can be revenue, it can be distance, it can be stadium, it can be capacity, it can be COVID, it can be GDP, it can be anything. In our case, are we maximizing Z or we are minimizing it? Okay.
So we are maximizing Z.
Okay. Now, what type of Z is Z? What is Z?
Z is a profit.
Maui.
Sir, please, Z is to maximize profit.
Yes, Z is profit. It's not Z is to maximize. Z is profit in this case. All right. So how do you write it? You write the Z and then you bring the max small as a subscript. This is how you write it. So you call it Z max, which means you are maximizing the Z. And now you are ready to write your objective function. This is how you write objective function. I'm not doing it for this one. I'm doing it general one. The objective function is made up of some number multiplying the x1 plus another number multiplying the x2. And of course, it continues if they are more than x2. The first number is supposed to be a number that you know, and it is associated with the first letter, which you know from the question. Remember, it's a number. We call it the coefficient. Write it down. A and B are the coefficients of x1 and x2 respectively. Okay. Now, what do you think A and B are here? Who can tell me first? What do you think A and B are in this very family example? In this story? Dinah.
Labor and milk.
Good. You have tried, but that is wrong. What do you think? Remember that what we have on the left-hand side is what? Is profit. Don't forget. And I've already told you that the A and B are numbers. They are not items. They are numbers. And already what we have here is profit. And so what do you think AX1 is talking about? It is a number multiplying a quantity. because the quantity was defined as number of sachets of. So whenever you have something multiplying quantity, what do we call that? And then, of course, that is going to lead to profit here. What do you normally call that? Something multiplying the quantity. What is that? Andrew.
Cost of production or price in this case.
Also, you are guessing or you are what?
No, it's cost of production.
It's on the left side. Be guided by what is on the left side. You see, what is on the left side is profit. So you should be guided by that.
So please, that could be the price.
It could be the price. Now, normally, if it is a price, then it means that AX1 is what? If it is a price, if A is a price and X1 is the quantity, then it means AX1 is what? This one.
X1 be the revenue.
Sorry?
Revenue.
It is the revenue. But do you think we are talking about a revenue here? Do you think that the company's objective is to increase revenue here? Gideon. Michael.
So I think that the variables here at play definitely is time and ingredients. So it's 40 hours and 120 gallons of milk.
Okay, we are guessing here. Because you didn't answer my question. My question I'm asking is that, do you think that A and B are revenues here? You know, because you said that A multiplied by the X1, okay, and you know, that will give you a revenue for the first one. And then B, are we talking about revenues in this story? What is objective, Richard?
Yes, so I think the A could be the unit price or the quantity. So unit price and quantity, as you said there. So the A could be unit price times quantity.
Well, why do you say times quantity again?
Oh, okay. A is already quantity, sorry.
Okay, let me go to another person. You are close, but you're not there. Max. Maud.
Sir, please. A is the individual cost of the number of Fanyogo, and then B is the individual
Was
cost.
there any mention of a cost in the story? Was there any mention of the cost of Fanyogo in the story? Yeah, remember to be guided by the story. That is how we are working. Be guided by the story. If you want me to go back to the story, I can do that for you. Yes, Fefe.
So, Doc, the A is the profit, assume profit will make the yogurt or the fine choco. No, for the for the yogurt, then for the fine yogurt, then the B will be for the assumed profit will make per unit on the fine choco.
Good. I like the word you use, per unit profit, because that's what the question was talking about. So it has taken care of the revenue and the cost. And therefore, what you have is just the profit. The profit per unit. Now, so A is going to be, if I were to produce just one sachet of Fine Yogo, how much profit am I going to get? That's what A is. B is, if I were to produce one Fine Choco, how much profit am I going to get? If I happen to know that, and I now produce 100 Fine Choco, then I will know the total profit I will make from Fine Choco. Now, in the story, A and B are represented by which numbers? You can raise your hand and tell me. Max.
Please, A is 40 and B is 50.
So how will you rewrite, and I'm going to delete this for you to rewrite. How will you rewrite now the objective function? How will you rewrite the objective function? If you were to rewrite it, how will it be? Please, if you don't know, lower your hand. If you know, keep your hand up. Yes, let me start with M. M, tell us. Patrick.
So hello, sir. So you write, should I write?
Wait, I'll write it.
Okay, so it's Z max is equal to.
Hold on. I think somebody is writing on my screen. Okay, so let's write it. Z max.
It's equal to 40x1 plus 50x2.
Very good. This is how the objective function is supposed to be. Guys, if you don't understand, say it now before we go to the next one. So what does the 50 here stand for? You can tell me. This is where you got to understand what you're doing. What does the 50 here stand for? Basically, relax and tell me practically. In this story, the 50 years is standing for what? What is that? Patrick.
So the 50 is standing for how much profit you are going to make if you sell one fan choco.
Correct. I love that word. I love that word you use, called one fan choco. So if we sell, let's say we sell one fan choco, they'll make a profit of 50. So if they sell 20 fan choco, how much profit do they make?
So that will be the 50 times the 20, which will give you 1,000.
Correct. That's it. So that will be the revenue generated from fan choco alone. And then we can talk about the fan choco.
So please, can you go over that question again? I missed that one. My line went.
I was saying that if one fan choco is 50 profit, 2 fan choco will be 100, 3 will be 150, 4 will be 200. So my question was, if we are to produce 20 fan choco, how much fan choco revenue do you think Pharma Ghana Limited will be? Does it make sense? And he said 1,000.
Okay.
It will be 50 times the 20, which is 1,000. Please, is that clear?
Yes, please.
Please, do you all understand how to write objective function? You'll be doing several of these applied to you. And you will do that also in the exam. Okay. Now, step 1 was to identify the decision variable. Step 2 was to formulate the objective function. Formulate here means write them down in numbers and letters. We just do that. Step 3 is to formulate the constraints. That is step 3. Formulate the constraints. Formulate the constraints. The most important part of this linear programming formulation is the constraint. So let's go back to the story and understand a bit of the constraint. The constraints are what are used to achieve the decision variables. I want to repeat that. The constraints are those items needed to achieve the decision variables. So before, in this case, before you can produce fan yogurt and fan choco, all of the items that you need and the restrictions on them, that is a constraint. Now, there are 2 kinds of constraints. we have resource constraints. Resource constraints. And then we also have mixed constraints. So we have resource constraints. And then we also have mixed constraints. What?
Sir, please. What?
Please resource and what?
Oh, let me repeat. You have resource constraints. Resource constraints. Then you have mixed constraints. We will not do the mixed constraints now. The resource constraints are basically resources that are used to produce the decision variable. In this very question, we have been given how many resources? And what are they? Patrick.
So, I think we've been given 2 resources, the labor time and then the gallons of milk.
Labor and what?
Labor time and then gallons of milk.
Perfect. I like the way you brought the gallon, the unit of measurement. So labor hours and gallons of milk. Always deal with the unit of measurement. So we are going to do the constraint based on these resources. That's it. There is a chart, an approach on how to write a constraint. So I'm going to show you that. There's an approach on how to write the constraints. Okay, so the first thing is that you got to indicate your writing of the constraint in 3 parts. This is the first part. You have to have something you have on the left side, which is known as left-hand side, or we call it usage. Usage, this is what you should write. So it's got 3 columns. The first is usage. The next is sign or symbol. And the last one on the right is available. Available. Another way of writing this is usage is normally given as left-hand side of the equation. A sign is given as the same symbol to use. And available is said to be the right-hand side of the equation. Now, how do you get a left-hand side? Well, the left-hand side of the equation is actually an amalgamation of things. Okay? You are trying to combine certain things together. Now, what are those? Well, first, you go to the story. Okay? And the story will tell you, and remember, you got the left-hand side should be written in the same order as the objective function. So just to remind you, the objective function was written as C max equal to 40 x1. So x1 comes first, then there's a plus, and then x2 comes second with this number. So in that same way, if I'm writing the usage, I should follow the same pattern as you can see me trying to do here. So the first must be the x1, which is the fan yogo. Then the second must be the x2, which is the fan choco. And this constraint must be labeled. So on the left here, or on the right, whichever one you want, you will now write the name of the constraint. The first constraint we are going to deal with is labor. So you write labor. That's the first constraint. Below that, what we've done, we'll go and do milk. That's another constraint we shall deal with. So let's deal with labor and see. That means that for labor, we need a certain quantity of labor to produce fine yogo. That is the first section here. Then we need a certain quantity of labor to produce fan choco. That is a section that you see here. So, and then we add them. That's going to be the left-hand side. When you look at the question, how many units of labor was needed to produce fan yogo, and how many was needed to produce fan choco? This is where intelligence comes to the fore. Who can tell me? Raise your hand. You can tell me, raise your hand. Patrick.
Okay, so we need 1 hour labor to produce fan yogo and then 2 hours to produce fan
So what will I write in the first circle here?
So you can write x1.
I should write what?
X1. 1x1.
Good. I like that 1x1 so that people will know, even though normally we don't write it like that, for people to know that there's 1 in front of it. So this is 1x1. The x1 is for yogo. And this comes from this point here. So you have to be reading carefully. We need 1 hour for fan yogo, which is here. And then continue. How will you write the next mathematical model?
So plus 2x2.
Plus 2x2. Very good. That is for the left-hand side, which is for labor. Now let's go to milk. Who will take milk for us? Guys, if you're feeling tired, go get some water or get some coconut drink. You see this coconut drink? Oh, what is that? You guys not seeing coconut drink. If you are not seeing coconut drink, how do you proceed? Yes, Irene, tell me. Irene, the door has been opened, hasn't it?
Yes, please.
Thank you. Walk in it. Let's go. Walk in it.
So please, for the constraints for the fan choco. No, sorry. Constraints for milk rather. It will be 4x1
x1
plus 3x2
plus 3x2. Very good. Excellent. Now, it is the most difficult part actually. The rest in the constraints are going to be easy. Guys, if you understand this, it's okay. If you don't understand this, let me know. This is the main important thing for this example. You should understand why you got a 1x1, 2x2, 4x1, 3x2. Okay. Now, what symbol are we going to use and why? Let me tell you why. Guys, the left-hand side refers to usage. That is what was used by Fan Milk Ghana Limited. The right-hand side deals with what is actually available. I'll give you a question. Suppose that I put $2 million into a room and I tell you to enter that room. What is the maximum amount of money you can take? What is the maximum amount of money you can take, Dinah?
$2 million.
Good. What are other possibilities?
I can take less than that.
What is that? What is less than that? Huh? Who spoke? What is that? Gideon?
1 million.
1 million or what?
Or 500.
500,000. Very good.
Also take none.
So if I were to put a symbol for the 2 million you can take, which is a maximum, what symbol would that be? When you enter the room, the maximum you can take is that 2 million. So what would that be? So take will be equal to, I've even said it. What symbol? If it.
to.
You want to
talk equal to.
Why equal to? Is it because I said it?
No, because that's the amount that is there that you've taken.
So what is the other symbol then? If it's not equal to?
There to be less than.
Very good. Equal. So ladies and gentlemen, there are three symbols you can deal with here. You can deal with equal to, you can deal with less than, you can deal with greater than, you can deal with less or equal to, you can deal with greater or equal to. These are the 5 symbols you can deal with in linear programming. Now, in this very example, how many, let's take labor first. How many labor hours is available? Do you remember? Who can tell us in this question? Fefe.
40.
40. So at the right-hand side, all you got to do is to write 40 there. 40 hours. Bring the unit. That's it. Now watch the word. The total hours available. So the word available deals with what is there. What is the total gallons of milk available? Who can tell us? Redeemer.
120.
120. So you write 120 on the right hand side
Gallons.
for gallons. And now the question is that if you look at what is on the left-hand side and what is on the right-hand side, the possibility is that you can use all, that's the word usage up here. You can use all the 40 hours, or it is possible that you will not use all the 40 hours. Do you agree with that?
Yes.
Why is that a possibility? By the way, that impossibility of using all brings about the less than. And then the possibility of using all brings about the equal to part. And it's the same thing with this one. Yes.
Sir, please can you flip to the other side of the question to confirm the figures?
I know the figures. They know the figures. That's why they said that. This is a 40. They know it already. I'm not kind of then 120. You know, somebody is dozing and somebody is seriously learning. Now, the one dozing is supposed to get up and walk. Please, is it clear now? Should I go to the next page?
Yes.
Okay. So now my question to you is that, yes, Daniel, go ahead.
No, sir, I got a bit lost. So with the calculation for the 1x plus the 2x and then the 4x1 plus the 3x1, I got lost into getting the 40 hours and then the 120. If you can just help.
Well, the 40 hours and the 120 was already in the question. So let's go up. Always whenever you are reading, look for the word available. In fact, even if you don't see the word available, you might see a word that is talking about a maximum capacity. So in this question, it said that there are 40 hours of labor available and 120 gallons of milk available each day, which means that the maximum resource is 40 hours and 120 gallons. And that is what should always be on the right-hand side. So it's not coming from the left-hand side. What is on the right-hand side is from the question. It's not coming from the left.
Okay, thanks, Doc. And then just to add up, the equation, are there factors that determine are you going either to use the greater than or the less than? Maybe if you can just highlight that place again.
Yes. So watch the word. The word is available. If I tell you that I have 200 bags of rice available, it means that you can take all the 200 or less than the 200, but you can't take more than 200 because more than 200 is not there. The word available itself is a clue. The word maximum is also a clue. If I tell you that the maximum number of hours in this company, that's another language I'm speaking. The maximum number of hours in this company is 40 hours. So you should not expect any number to be more than 40. So the symbol should be less or equal to 40. In fact, that is how most of them are anyway. Does that make sense?
Yes.
Okay, my question to you all is this. Why is there a less than? What does a less than here mean? Why not it all being equal to? What is a practical justification for the less than? You can tell me. What is a practical mod?
Sir, please, the practical justification for the 40 is you can have labor that would not work or will have excuses, have off days, or we can have milk that can spill, that can get stuck in the machine.
Which therefore means that
we are using less or equal to what we have available.
and you forget about the equal to, because equal to, we have spoken about it already, isn't it? So we are using what?
We are using less of what we have available.
Okay.
Just a minute. Let me come. Then put your wrist in
So,
your face.
you can mute yourself. Who is making the noises? I think somebody is not paying attention and the person is disturbing everyone. Okay. So what you said is correct, but what does that mean for the company? What does that mean if you are an analyst, a consultant, and you are advising management and they are using less of the labor? What does that mean? Samuel, this is practical things. I'm only asking you these questions before we get to them. Samuel.
Yes, Doc, I even had a different opinion from what she said. I also think that even though there's 40 hours available and 120 gallons, there's a probability that you can use less hours. That is, if whatever you are doing is very efficient. If your workers are really working hard and your processes are optimized, you can use less hours.
What will make them use that? What will make them? We have identified. Do you know why people work 40 hours a week? You know, this is a standard thing everywhere in the world.
Yes. 8 hours a day. Yeah.
Yeah.
And 5
So
hours.
why is it 40 hours a week?
40 hours a week. Yes.
That's what is available.
Yes.
So if go ahead.
Yes. So from my point, we can use less and save on the hours and the gallons, or from what she said, if they spill some, what it means is that at the end of the day, it is going to be a cost to the company and then going to affect the profit.
That is why that spilling some, I am saying that it is an indication of what? Remember, resources are limited. Resources are difficult to come by. And here you have 120 gallons of milk, and you are spilling some. Accidentally or not accidentally, it is an indication of what? On the right way.
It's wastage. You are wasting it.
It's wastage. It's inefficiency.
Yeah. Yeah, inefficiency. Yeah.
So guys, that 120 gallons of oil has to be used for efficiency to be attained. Resources are limited. When you get them, use them. Use them judiciously and use them ultimately. Now, you see this a lot in the ministries, the government institution. When you get there, the moment the person gets to the office, he takes Graphic, Times, Spectators from Saturday, and then he starts reading them, isn't it? By the time he finishes reading them, it's already 11 o'clock. Then he will tell his friends that, it's 11 now. So it's almost lunchtime. Already 4 hours is gone. Nothing is done. His colleagues are watching cantata. Wait. And so that is why most government institutions are inefficient. That is why there are lots of wastages. But most private institutions are efficient because they do not endorse you being idle. Resources gotta be not idle. Resources gotta be utilized. Resources gotta be utilized. And in the utilization of resources means you are maximizing the existing resources. And so you gotta use, if you don't use the available resources, you are inefficient in that particular resource. You are wasting that resource. And we'll come back to this because you will later see that it is called slacks. So, but why is it less than or equal to? The less than or equal to is indicating that even though you want some of them or all of them to use all the available hours, utilize it because it's been given to you. Do you know that if you're supposed to go to work and work 8 hours a day, and then you don't go to work, or you got to work at 12, and then after 12, you went to lunch, that 4 hours is already gone. Are you aware? It's wasted. The problem is that people don't quantify that into the company. If you quantify that into the company, you will see that even though you are number one in that industry, you are wasting resources. You are exhibiting slacks. And that is why this programming approach is good. It will help you bring about all the inefficiencies in the system. If you understand it, you can. I've done this for companies where I tell them the inefficiencies, and then I recommend that some people should be fired. Of course, I don't let them see me, because if they see me, they'll kill me. Okay. And then the moment these people are fired, straight away you see the revenue coming up, profits going up. Why? Because these people are just idle resources. They are doing nothing. They are adding nothing to the company. So removing them, firing them does not punish the company. Do you get me? Meanwhile, they were there taking money, salaries. Resources have to be fully, not partly, fully utilized. But of course, inefficiency is possible, isn't it? We are not saying that it won't happen. It will happen that in some industries, in some companies, inefficiency will be there. Even in private companies, some inefficiencies will be there. That is why we have the less than. The less than is indicating the possibility of inefficiency. Write it down. You'll forget. I'll ask you these things in midterm exams. It's indicating the possibility of inefficiency. It's indicating wastages. I hope you get it.
Doc, please, I have a question.
Right.
So, Doc, please, is this the procedure for getting the usage of the of the production that we have? Or because I was also thinking if we can formulate another thing, maybe because we know labor to be 40, then if we know that 40 minus the 2x2, the 2x2 plus the 120, which is for the gallon available minus the 3s2, then that means we'll be having x1 for s1's production. Or this is a standardized.
We have x1 production. It's when we are not producing x2.
Yes, please.
The only way we will only have x1 production is when we have stopped producing fan choco. Guys, we have to produce fan choco. This is it. The company has given us the resources you got to use for fan choco, the resources you got to use for fan yogo. Use it, but use it efficiently. That's it. But the thing is that even though you tell people that work and work efficiently, they won't work efficiently. Some won't work efficiently. That aspect of some will not be efficient is the reason why we have brought the less than symbol. Those that work efficiently will be the equal to part. Those that work inefficiently will be the less than part. Dinah.
Thank you. So is the less than or equal to constant? Or there are some situations where we will see equal to?
There are some situations we will see equal to. There are even situations where you will see greater than. All of them will be from the language. We'll get to that as we move further.
Okay, thank you.
Yeah. Dede?
Yes, sir. Please, I want to ask that in a normal work setting, don't we make room for errors?
apart from human wastage, as in somebody not being efficient or somebody not coming to work on time, don't we make room for, especially looking at this, saying that 120 gallons of milk available? It may happen that everybody is working efficiently, but something happened somewhere which was beyond the
Let me tell you something. This is something that people in Africa endorse. Outside, nothing happens somewhere. Somebody has to be fired. Simple. Somebody got to go down. Yeah.
So what if it was a mechanical problem?
That is even more dangerous. Somebody has to be fired. If it is a mechanical problem, somebody has to go down. I'm telling you. These models were not designed for those possibilities. Those possibilities are human errors. Somebody has to check and make sure that that mechanical issue does not happen in the first place, because it was not happening before. So you got to put all the tools at a proper place. You check them before you close for work. If you like, bring any other thing, and I'll tell you that somebody has gone down for it. That is why, you see, these are some of the things that we tamper with people. If there are critical issues, let's say environmental factors, like if there is tsunami or if there is COVID-19, and therefore we can't go to work. Okay, we can't go to work because of COVID-19. That is a general phenomenon. If someone is pregnant, that pregnancy can be factored out into the whole thing, but not mechanical issues or things that can be controlled. So maybe you are right. You only gave a wrong example. Did it? Does that make sense?
Yes, sir. I agree.
Yeah.
Yeah, I think maybe there is an example I gave, because what was in my mind is exactly what you are saying. Something that's beyond your control.
If it's beyond your control, we would have already factored that into the picture.
Mm.
Yeah, we would have created a
so
damage.
this my
Sorry?
Yes, my last example, I don't know if you heard, I think early this year, Ideal Milk. It got a point in time when they were producing milk that the milk was very thick, that when you open it comes, I personally faced that. So with that happened at a point in time, I think that the milk was not selling until they issued a statement and all that before the milk started selling again. So I'm seeing to issues like that we know
Somebody should
that
have
is
been
not the
fired,
norm.
not somebody. People should have been fired from the company. That's what should have happened. Production manager should step down. Marketing manager should step down. That's what you do outside. But we entertain those things. If somebody is fired, the next person will make sure that meticulousness is applied. You see what happens abroad, and prime ministers are stepping down. You understand? You know what happened, and prime ministers are stepping down in the UK in the past. Do you think that it will happen in your country? In your country, somebody will take this and will do hey, and then will even tell you that, tighten your belt and things like that. Because we have allowed these things. Nobody is fired. So many human errors, That's why there are a lot of inefficiencies in government control. That's why there's also a lot of corruption, because there's no punishment. Do you know why people are paid based on hours in US and America? They are not paid on the day you come to work, but the hours you work. You know that. So the person will come to work, he says he have gone to work for 8 hours, but he actually worked 4 hours. Why should the manager have a TV in his room? You won't get that abroad. You won't get that in the US. Unless it's part of your job. And then you enter the manager, the director's office, then he has TV. And then they are doing cantata. And they are doing brilliance and mask. Okay? Yes, tell you. Jacob, go ahead.
Yes, sir. Say, let's say in the cocoa industry, At the time you are storing the goods, there is a moisture of about 4%. Then at the time you are shipping the goods, the moisture declined from 4 to 2%. That means the tonnage of the cocoa will reduce. In that aspect, should someone go down?
That is an environmental factor. What caused that reduction?
That is the moisture lost.
Yeah, nobody has control over that, right?
Exactly.
Yes. So if it is not a human error, I don't know whether that was a human error. If it is not a human error, that should make sure that a person should put this thing somewhere for the moisture not to come in the first place. If it is not a human error, that will be modeled into the whole thing. Let me tell you guys, I've done such things before. Let me talk about agricultural productivity. Okay? Sometimes you don't have control because agriculture depends on the weather. So when you have a bumper harvest, 50,000 this particular month, and then the subsequent month you get down to 20,000. And you realize that the issue is not human error, but it's because of the season. So in this case, it is the season which you don't have control. It's the weather. There was no rain. You cannot manufacture rain. But where they have put irrigation system that manufactures rain, do you know Dubai manufactures rain? Dubai is manufacturing rain. In such a case, somebody has to be fired. But if not, you will model the uncertainties. Now you are talking about is the uncertainties. You model the uncertainties into the picture. Jacob, do you get it?
Yes, sir.
Yeah. Yeah, I can model uncertainties into this. I can. It's not at your level. If I started, some of you collapse. All right, let's move on. So let's look at the final thing. There's one more constraint. It is not inside the story, but it is implicit, and it is called non-negativity constraint. So you have the labor constraint, you have the milk constraint. The last constraint is called non-negativity. Write it down. Non-negativity. That constraint is saying that you should put a clause that says that all the decision variables are at least 0. So they are either 0 or positive, which means they are at least 0. That constraint is written as x1, and then x2. Both of them should be greater or equal to 0. This is a non-negativity constraint, which means that we don't want any of the values to be non-producible or to generate a negative returns. So you restrict that and make sure that everything is 0 or positive. I mean, the least you can do is that you don't produce. But if you rather come and produce a disease, you have brought a lot of negativities into the picture. Yes, Daniel.
Listen, I got the equation and all, but can you help repeat the definition of the non-negativity constraint again? Just the definition.
The non-negativity constraint is a constraint that says that none of the decision variables should be negative. None of them should be negative. Yes, Kweku.
So are you saying that the non-negativity variables, you always have to
assume?
You always, you assume that they are always constant.
No, not that they are always constant. You assume that they are always not negative. Don't think too much. I know you are thinking too much. If you don't think it, you don't understand. You start thinking and then you get confused as to what do I mean by they are not negative. If you are producing fan sachet, fan yogurt, you are producing 20 sachets. That is positive. 10 sachets. That is positive. If you are not producing anything, that is allowed to. But you can't tell me that I have just produced a fan yogurt that is not even needed. Like I'm supposed to produce fan yogo, and then the thing came out as not fan yogo. That's a negativity. It doesn't make sense. It's not normal. And we are not encouraging that abnormality. It's a mathematical way to close the system. You see it if you draw a Cartesian plane. Okay? 0 is a starting point. Okay? Anything here is negative. Anything below is negative. And you don't want that. Everything should be on the first quadrant. Okay? It should all be on the first quadrant. All right, let's move on. This is not a... So let's look at the final answer. This is the final model. Look at the model carefully. This is what you will be told to model yourself. I will give you an assignment that will require you to read a certain case study and come out with your own mathematical model like this. But remember that that will be a little bit more difficult than this. Okay. Now that you have produced this model, let's try to solve it. That's the next thing. You are ready to solve this. If you don't understand, just write this equation down. Write this whole thing down. Instead of the z max here, I wrote max first. It's the same thing. Or you can write the z and rather put the max as the subscript. It's also the same thing. If you don't understand what you are seeing on your screen, equation 1, 2, 3, 4, let me know. How do you solve this? Oh, by the way, what are we solving? We are looking for the x's. What is the value of the x1? Those are the decision variables. What is the value of the x2? Those are the decision variables. Our goal is to find these variables and then put them down. There are 3 ways of solving them. 1, you can use graphical approach. You can use the simplest algorithm, the one by George Danzig. That will use mathematics, and you can use the PC. The PC is also based on the simplest algorithm, the Excel. We shall use Excel for this a lot. We'll not do the Excel today. We'll do the graphical and then the algebra right now. So how do you solve this? Guys, please open your eyes. The first thing you want to do is to draw. How do you draw? Well, this is how you draw. Follow me. Pay attention. Follow. Now, the first thing you have to draw is to draw the non-negativity constraint, the last one. The non-negativity constraint starts from 0. So you just have to draw a Cartesian plane, label one axis to be x1, label the other axis to be x2. So I'm going to draw this Cartesian plane here. Okay. I'll call the one on the x-axis to be x1. I'll call the one on the y-axis to be x2. Okay, so you have x1 and then x2. Now here is 0. And that is why we call this equation 4 the non-negativity constraint. So we draw that one first. Do that in your book. The next thing you do is to plot the other 2 constraints. You always start with a constraint. You can start with any one of them and plot it. Now, each one is an equation of a line. An equation of a line is something like y is equal to mx plus c. That's an equation of a line, where you are supposed to assume that if x is 0, what is y? And if y is 0, what is x? So that's what we are going to do. We are going to take the first one. Remember that the symbols there are less than or equal to. For simplicity, you will use the equal to sign because that's the maximum. So we will rewrite this equation as the first equation 2 as x1. I have removed the 1 plus 2x2 equal to 40. That's how you write it. Then you ask yourself, if x2 is 0, what is x1? Who can tell me? If x2 here is 0, you multiply 2 times 0, so what will be x1? Victor. Patrick.
X1 be 40.
It will be 40. Then you come to your axis here, the X1 axis. Identify any portion that is reasonable and call it 40. So I've just identified a portion here and I've called it 40. X1 is 40. Then you go back to your equation up here again. What if X1 is rather 0? What will be X2? Who can tell us? Jacob.
It will be 20.
That's it. It will be 20. So here, what you do is that you identify a portion here. Because this is 40, the middle of this will be 20. So I'm using that same kind of gauge mark to identify this one and call it 20. You will join the two because this is a straight line to create a line. In order to create a line, you always need just 2 points. So now I'm ready. I've joined this one to this, and then you have formed your first constraint. Now, the line is indicating the equality. Anything below the line, which is a space, is indicating the inequality part, the less than part. Anything below is a less than part. Anything between 20 and 40 is the equality part. Sika?
Sir, the equation x1 plus 2x2 is equal to 40. I just want to know, because you said, let's assume. I just want to know how you came about that equation.
I came about that equation
Afterwards, I understand, but just how you get on.
because I wanted to draw a straight line.
Okay.
Anytime you want to draw a straight line, if you read Akiola, I will tell you, if you want to draw a straight line, you just assume, if there is inequality, you just assume the equality part, because that's what you know. Everything else below that equality part is the inequality part. Everything above the equality part is the greater than part. So you don't need to go and think about how will I make this equality. No, just assume the equality, and then the rest will automatically be what is above it or below it. It's a space. So
is it a constant formula?
yes. Anytime you are doing it, that's what you do. To create a line. Anytime you want to create a line, that's what you do.
Okay, sir. Thank you.
Now we go to the next equation here. And in this next equation, we do the same thing. Okay. Once again, we assume that this equation is actually 4x1 plus 3x2. I'm writing it again. You should do the same thing. Then instead of the inequality, you bring equality. Just as I've said. Then you assume that if x2, because I'm creating a line, and if I'm creating a line, I should assume that x2 is not there. What is x1? X1 is not there. What is x2? If you check the slides, you see all this. By the way, if x2 is 0, x1 will be what? It will be 120 divided by 4, and that will be 30. So that will be somewhere here. Okay. So I will just use a different color and then mark this section. Okay. And then I'll write 30. Hey, is it 30 or 40?
30.
Yeah, it's 30.
It's 30.
And then if x1 is 0, what is x2?
40.
40. 40.
40. Okay, so you go here and then you label this side and call it 40. Now you can join the 2 points. Okay, and so you join this one to this, and that creates another space. So what it means is that anything below this space, anything below this blue space, below the blue line, is the less than part. It is anything below 20 space. If you look at that line carefully, it is like a triangle. All right. Andrew.
Yes, please.
Go ahead.
Sorry, I think my hand slipped and then clicked on the.
All right, okay.
Please.
So now you are done. You are now ready to solve the solution. Ladies and gentlemen, let me tell you the names of some of the things you've done. The blue thing you did is the milk constraint. So you give it a name. That's a milk constraint. The red one you did is the labor constraint. So you label it. The labor constraint area is anything below the red line. The milk constraint area is anything below the blue line or the space below. Now, pay attention. In order to find, and by the way, there is an area that is common to both of them. There's an area that is common to both the labor constraint and then the milk constraint. If you look at what I'm showing here, A, capital B, and capital C. Which area is labor constraint area? Let's deal with that first. Who can tell me? Which area is labor constraint area? Which area?
Is it B and C?
Is B and C. What about milk constraint area?
A and B.
Good. Which area is a common area?
B.
B. Now, listen. In order to, by the way, so let me indicate this first. So this area is called the feasible solution area. The common area is known as the feasible solution area. Take note. It is that area that is common to both the constraints. Your answer you're looking for, the value of your x1, remember the whole space that you are seeing here, all of this space and all of this space, they are referring to the x1 and x2. Now, you are looking for a unit of x1 and a unit of x2 that will satisfy this common area, this feasible solution area. You're looking for a point. So first you find the area, and then you look at the vertices of the area. Pay attention, write it down. Look at the vertices of the feasible solution area. One of the vertices is your optimal solution point. One of the vertices is your optimal solution point. One of the vertices is your optimal solution point. So what are the vertices? Well, if you look at the feasible solution area, one vertex is at number 20. Okay, let's call it small a. Another vertex is at number 30. Let's call it small c. And then another vertex or corner point, another name for the vertex is corner point or corner solution, is at the intersection between the blue line and the red line. And that, let's call it small b. One of these, in fact, another vertex is the 0, but we don't need the 0. One of these vertices, B, C, is our optimal solution point. Which one? Now, in order to determine which one, you got to know the value of each one, and then substitute each value to the objective function. The one that will make the objective function biggest is the optimal solution. I want to repeat that. First, you need to find the coordinates of each of these corner points. You have to find the coordinates of each of these vertices. You know, that area is a kind of a polyhedra. It's a quadrilateral because it has 4 lines. It can be a polygon, not a polygon, quadrilateral. It can be like a parallelogram, a trapezium, trapezoid, you know, kite or anything, rhombus. Whatever it is, yeah. What we care is that one of the vertices, we need to know the coordinates because each vertices will have a value for x1 and x2. Each vertex will have a value for x1 and x2. Let's start with A. Let's identify the values. What are the coordinates for x1 first? At A, the value of x1 is what? Gideon. At point 0. And then the value of x2 is what?
20.
20. So that one is cool. Let's go to C. Please mute yourself. When you go to C, the value of x1 is what? Who can tell me? Patrick.
30.
X1 is 30.
0 and 30.
Okay, hold on. And then what about x2?
0.
X2 is 0.
Now, it is the B that we have to calculate ourselves.
Sir, please, can we go over that again?
Go over which one? My dear, I told you that when you miss a point, like a child disturbs you in the house, something cracks you, something changes, you will tell me I should go over. When in fact, I'm going so slow that you should not get lost. I said at point A, we are looking for the values of x1 and x2. At point A, x1 is 0, x2 is 20. And by the way, you should go and read Akiola, because Akiola shows you how to plot lines and how to do all of this. Aaron, your hand is up. And then at point B, point C here. Point C, if you look at point C here, what is the value there? X1 is on this line, so X1 is 30. X2 is 0.
Sir, please, sorry for interjecting, but please, I got lost right at FSA.
Oh, don't worry. When you watch the video again, you get it. Because this, for yours, you are taking us quite far. You are not taking us on something we just did. We will delay everyone. So the values you get for this point, because I told you that our goal is to find the points, the coordinates of each point. And anytime you are finding the coordinates of a point, you are looking for the values of x1 and x2. Now, at point small a, we know that x1 is 0, but x2 is 20. That's it. At point B, C, we know x1 is 30, and then x2 is 0. Now, what about point B? We have to calculate. How do we calculate? The two lines are straight lines. Anytime two lines are meeting, the values of them can be solved simultaneously. And where are those two lines coming from? The two lines are coming from these two equations. So you must remember your simultaneous equation.
So I wanted to say that we'll solve a simultaneous equation, but you've already
All right, okay, no problem. So once you solve it simultaneously, who has gotten the answer? By the way, you can go home and go and solve it simultaneously. I don't need to do that here. I taught you guys, statistics and mathematics for data science. If you solve this, please mute yourself. If you solve this equation simultaneously, your x1 will be equal to 24, your x2 will be equal to 8. So your point B will be 24 and then 8. I'm not going to show you how to do that. You can do that yourself. I showed you how to use matrices and how to use normal simultaneous to do this. Okay. So now the question is that which of these points is the optimal solution point? Only one of them is in this context. Which one? In order to know which one is, take them one by one and substitute them into the objective function. Take them one by one and substitute them into the objective function. What is objective function? What is at the top here? The objective function is z equal to blah, 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 blah. Okay. So I'm going to take A first. And then whenever I see x1, I'll put 0 here. Whenever I see x2, I'll put 20 there. So I'm doing for A. So I'll call it simply like ZA. ZA is going to be 40 times x1. And x1 is what? Let me do bracket. 40
X1 is 0.
X1 is what?
0.
So you put 0. Plus 50 times x2. What is x2?
20.
Somebody should find the answer. Let's go to B, ZB. B is going to be 40 times x1. X1 is what?
X1 is 24.
Plus 50 times x2. X2 is what?
8.
Someone should find the answer. What do you have to point your calculator and find anything? Now, at least what you can do is to find the answers. Let's go to C. C is going to be 40 times x1. X1 is what? 30. X2 is 0, so I don't want to do that one. So what is the value of the Z value at point A?
1,000.
Sorry?
1,000.
Yeah, 1,000. At point B?
1,360.
1,316.
And then at point C?
1,200.
1,200.
1,200.
So you ask yourself, which one gives you the highest profit? Point
B.
B.
Point
Therefore, the optimal solution point is 24 for X1 and 8 for X2. In simple English, the amount that the company should produce in order to make the maximum profit of 1,360 is to produce 24 units of Fan Yogo and 8 units of Fan Choco. Now, everything that I've done is here. I'm clearing all of this. And when you go here, you will see that everything that I've done. Okay. The non-negativity constraint, how to find X1 is equal to this, X is how to draw each one of them. I've shown it all here. Okay. And then you have all of these. Okay. And then finally, the optimal solution point. This one gave us 1,000. This one gave us 1,360. This one gave us 1,002. Okay. And then this is a simultaneous equation solution. It's all done. So if Fan Milk Ghana Limited produces 24 Yogo and 8 Choco, it gets 1,360. That is the optimal solution. There are several other questions I can ask you here, but that will be for later. Now, what we have just done is very, very important because it just goes to show that you can use linear program to determine the highest profit a company can produce. And you can also know the exact amount to produce in order to make that highest profit. You can go with maximum capacity of spectators. You can go with any other thing. But that is how you do it. Next time, we are going to look at converting this to the standard form. We'll look at other areas of the slacks. Okay, and then we'll look at irregular types of linear program. I'm done. Any question, please? At this stage, you can ask question for something that wasn't clear, and then we can address that. But hey, this is if you can understand a little bit of this, okay? And I know some of you understand a full bit of it. If you can understand a little bit of it, hallelujah. Let's go to Samuel. You have a question?
Yes, Doc, I wanted to find out that, is it that at any point in time, the intersections are the optimum?
Not so. It can be at the corner point. That is not an intersection. Yeah.
Okay.
As long as when you put the coordinates in, it gives you the highest profit or the lowest cost, then it is what it is. Irene.
Doc, please, I wanted to find out the definition for the feasible solution area and then that of the optimal solution area. That's all.
So the feasible solution area is that when you draw for each one of them, okay, when you draw for each constraint, you are going to draw an area because it's a line. See, when you look at the whole thing like this, let me use a different color. When you look at the whole thing, it's a line. It's a line. So you have your x2, x1, you have your x2. And it's a line. So I can draw this line, draw another line, draw another line, draw another line, draw another line, okay, and so forth. Okay. It can be any number of lines. Now, in this line that I've drawn, this part here is not the feasible solution area because it's outside those that are common. It's not even part of the common ones. It is this area, is an area that is only common between this horizontal line and this vertical line. Okay. So it's not part. This line, this second horizontal line, this corner here is a point that is a respectable point. This one is another point. That is another respectable point. You can't go to this one. This is not correct because it's behind. This point is another respectable point because the feasible solution area is here. It's an area that is common to everyone, almost everyone. So, and this final one, yeah, it's another point. So the feasible solution area is an area that each constraint you have drawn is having a say. Let's put it that way. Each constraint you have drawn has a say. I mean, the one we did was easy. If you look at this, if I draw this one, okay, and then I draw this one, okay, the feasible solution area will be this point to this point to this point and the space below. That becomes the feasible solution area. It is an area that is common to all of them. It depends on the number of constraints you draw. Once you identify the area, then the area will surely be a quadrilateral or a polygon. For example, my own on the right here is like a polygon. It has one side, another side, that's two, another side, that's three, another side, that's four, another side, that's five. So that's like a pentagon, okay, a polygon. Now, any figure like that, it will have corners, it will have vertices. And again, you should go and read. It will have vertices. And those vertices, one of them is also a point that satisfies profitability. That is the highest profitability or the lowest cost. So you just have to put the point on each of those into the objective to see which one will give you higher profit if you are dealing with profit, or will give you lower cost if you are dealing with cost. That point becomes the optimal solution point. So the optimal solution point is always one of the vertices of the feasible solution area. Write that down. The optimal solution point is always one of the vertices of the feasible solution area. I hope I've answered your question.
Yes, please. Thank you.
Daniel. Daniel, go ahead. Oh, Daniel is sorted. All right, ladies and gentlemen, that brings us to the end of the entire caboodle. Okay, I'll get this recording ready for you. It's been a pleasure having all of you. What a day to start. What a day. What a dia to start this. And I know that you're going to watch this to expand it. Don't wait. Don't go and put it under your carpet and then come for the next one, because the next time we come for the next one, it will be an add-on. It's a build-up of what you know. So refresh your mind of this, and then we will get that build-up.